chance. Of course, today's lecture, like I said, is going to be aired online. Um, and give me 1 second. I'm actually going to upload, going to share my lecture slide right now. Okay, so I actually need someone to confirm if you're seeing my lecture slide. Is everyone see my lecture slide? Okay, thank you so much for confirming that. I want to welcome you to this to my lecture today. So this is going to be the end of chapter 9. And of course, it is a 1 and 2 sample estimation problem part 3. And of course, is going to be based on proportions. So what we intend to do today is actually to, talk about the confidence interval for proportion and also talk about the confidence interval for difference of proportions. Before now, I've walked you through how to construct a confidence interval on the mean and difference of means. And I remember in class on Monday, I actually walk you through how to construct a confidence interval for the mean of the difference, the one that has to do with the dependent groups. But today, the focus is actually going to be on proportion. At times, what we may want to estimate may actually be proportion instead of the mean. So how do we estimate proportion for one population, and how do we construct confidence interval for that, and how do we do that for two populations, and how do we construct the confidence interval for that? That would be the focus of today. Okay, so I need you to pay attention to this guy here. Of course, that is a formula for constructing a confidence interval for proportion. And all what I'm just trying to say there is that the true value of proportion will lies between the lower bound and the upper bound. This is the true value of proportion, the one without a cap. And this guy here is a lower bound, and this guy here is an upper bound. So all what we're trying to say is that at the end, we expect the true value of proportion to lie between the lower bound and the upper bound. Another thing I wanted to say, this guy here is actually the sample proportion, okay, which is I also refer to as a point estimate of a proportion. A point estimate of a proportion is only going to give you a single result. And I told you in class, a single result could be wrong or right. And that is the reason why we need to incorporate the margin of error. As you can see, what I circle right now is the margin of error. We subtracted that from the point estimate of proportion, and we added that to that. We also have another method that we call the second method, but you know what, this method is not popular, so I will advise that you actually stick to the first method. Okay, so I'm going to have an example on that right now. So want to have an example on on this very one right now. So in a random sample of n equal to 500 families owning television set in the city of Hamilton, Canada, it is found that X equal to 340 subscribe to HBO. Now find a 95% confidence interval for the actual proportion of families with television sets in this city that subscribe to HBO. Now, when you take a look at the question here, okay, you're actually going to see that they only investigated 500 families. They take a random sample of 500 families among the population of families in the city of Hamilton, Canada. So which means it is not every family that was investigated. And why are they investigating them? They really want to know uh, how many of these 500 family actually subscribe to HBO. Okay, so I want to believe HBO is actually a television set in the city. Okay, and they wanted to construct a 95% confidence interval for the actual proportion of family with the television set. Now, what you're going to start is to start by calculating your sample proportion that I'm actually calling PCAP. That's going to be the number of the characteristics of interest divided by the totality. So the formula we use here is just P cap equal X over N. So X in this case is the 340 that subscribe to HBO out of 500. The 500 here is the sample size. So if I want to look at the point estimate now, 0.68 become the point estimate. Now, after getting the point estimate, of course, I told you the other time, we needed to compute the margin of error. If you go back to the formula here, okay, we actually going to start plugging in what is our P. Our P cap is 0.68, and the P cap here is just going to be 1 minus P cap, 1 minus 0.68, okay? I know my N, and of course, what about the Z alpha over 2? Okay, now if I want to I need to go to the table to get the Z alpha over 2. But if I want to get the Z alpha over 2, I need to look at the level of confidence. It's actually 95%. And if I want to get, my alpha is going to be 1 minus 0.95. 95% is 0.95. And in this case, alpha is going to be 0.05. Okay, and when alpha equal to 0.05, all what you just need to do is to divide that by 2. So 0.05 divided by 2, that is going to give you 0.025. So by the time you go into a normal table, table 8.3 in the textbook, you're actually going to check what is the under the level of significance 0.025. Okay, what is the values of Z? Of course, the values of Z is going to be 1.96, and that is what we plug in here. And of course, don't forget this is a P cap, this is a Q cap, and this is the sample size. So by the time you simplify that, you're actually going to come out, you're going to have that as results. Okay, now if you want to interpret the result right now, you need to put into consideration the level of confidence given. Now, this is going to be interpreted as, we are 95% confident. We are 95% confident, that the true proportion, the actual proportion of families with television set in the city is actually going to lie between 63.91% and 72, 0.09%. So you can actually interpret that in terms of proportion, which is going to be 0.63912 to 0.7209, or you multiply by 100 if you want to interpret that in terms of percentage. But you know what? Whenever you want to interpret that, you need to mention the level of significance given. Now, before I move on, is there anyone here who doesn't understand this page? Is there anyone? I need I need everyone to confirm again if you are still hearing me clearly. Is everyone still hearing me clearly?
Yep, I can hear you.
Thank you so much. Thank you for confirming that. Now, the silence implies that you all get it right. So I'm going to go to the next page. Now, on the next page now, we actually want to talk about comparing two groups. Okay, when we're focusing on the mean the other time, we also consider situation. I remember in the last class where we compare means, in two groups, two independent groups. We can also do the same to proportions. Okay. Now, if you take a look at the example here, compare average GRE score before and after taking a prep score course. If you take a look at this example, this is actually the paired, observations that we did on Monday, okay, because GR score before and after, because they were using the same student, the same subject, except that they are actually taking data into occasion that is you're actually going to use a paired, that's going to be using the knowledge of dependent groups, because in exam you're actually going to be the one that will figure out when you're given a question, is it going to be, are they talking about comparing to independent groups, or they are actually talking about dependent groups. But I need you to pay attention to this guy here. Compare the proportion of Minnesotans who hold guns to the proportion of Wisconsinite who owns guns. Now, when you take a look at this, there's going to be a difference of proportions. We're talking about proportion now. We're not interested in everyone. Here the focus is on Minnesotans that own guns. It's not all Minnesota that owns guns. So this is a question on difference of proportions. Because two entities are involved, there's going to be a difference of proportions. We have other examples that we can cite here. What if I want to compare the proportion of women in the United States Congress and the Canadian Parliament? Or what if I want to compare the proportion of those who actually catch COVID, after they get vaccinated with Pfizer vaccine, and some will get vaccinated with Johnson and Johnson vaccine. So we can compare infection rate, between the two groups. The moment you're focusing on that, you're focusing on difference of proportions. Okay, so in comparing proportions, we actually got a goal. The goal is to compare two unknown proportions corresponding to two independent samples. So whenever we're comparing proportion, the samples have to be independent. Okay, and what is going to be the procedure here? The procedure is actually we're going to take two different samples from two different population, and what we're going to do is to count up the number of successes in each. Counting up the numbers of successes in each is counting the number of characteristics of interest in each of that. The example I gave the other time about comparing two vaccines, when the essence of vaccine is to prevent or maybe a disease. Now, if actually vaccinate two different group with two different vaccine, and at the end of the day, I'm actually going to I can count the number in each group that was not able to catch the disease. Okay, because we want to see whether there's a significant difference between the two vaccines. Okay, so now, mathematically speaking, we're actually going to have two populations, like I said. And what are we actually seeking for? We're seeking for P1 and P2. The P1 here is going to be the true population proportion, and the P2 for the first population, and the P2 is going to be the true population proportion for the second one. And there's no way we're going to study every element in the population. What we're normally going to do is to take a sample, right? So you take a look at this guy now. I'm going to take a sample of N1 from the first population, take a sample of N2 from the second population. And from the sample of N1, X1 is going to be the number of characteristics of interest that I'm actually looking for. And then in the first population, and the X2 is going to be the number of characteristics of interest that I observe in the sample. And of course, the moment I have these two information, then I will be able to obtain my sample proportion for, for the first and the second. So there's a difference between this guy and this guy. Okay, you can see here, that is a population proportion, and this is the sample proportions. I needed to take a look at that. So actually, what we're looking for is the difference of the population proportion, but because of the assumptions we've made before by way of sampling distribution, we actually have a simplified en route to statistical inference. So we can actually say, okay, if the distribution of the difference of this guy here, the pickup one and the pickup two, if you look at the sampling distribution of this difference and they actually follow normal distribution, then we can boastfully say the expected value of the difference is actually going to give us the true difference of the proportions we are anticipating. Okay, so now like I said, we are actually on the lookout for the P1 minus P2. Okay, we can get the point estimate. We can also get the interval estimate. We can also conduct hypothesis about that. Of course, the hypothesis will actually be next topic that we're going to talk about. Now, I need you to take a look at what I'm going to be showing right now. Okay, I needed to be showing, what I'm going to show now, the point estimate of P1 minus P2 is actually P cap 1 minus P cap 2. I'm going to say that again. What we're looking for is actually P1, minus P2. Okay, and of course, the P cap 1 minus P cap 2 is going to be the point estimate of that. And by way of sampling distribution, okay, if 1,000 investigators should go into the two population, take sample size, compute the pickup one and pickup two, they're actually going to have different values for that. So because of that, this difference that I circle right now become a random variable. And if you plot the histogram of this and this follow normal distribution, then we can actually say, okay, the mean is going to be this and the standard deviation is going to be that. Okay, the moment that follows normal distribution. Okay, now because of that, what we're going to do, we're now going to impose this guy. We're going to say, okay, you know what, by central limit theorem, if the sample size that we choose from the two populations are large enough, okay, if they are sufficiently large, okay, then the sampling distribution of the point estimate, that is the pickup one minus pickup two, will approximately follow normal distribution. And what we're trying to tell the world is going to be the mean. And this is going to be the standard deviation of that. That's what we mean. And and if we say how large is large enough, you remember when we're focusing on the means, we said the sample size has to be at least 30. But when we're focusing on the proportions right now, okay, all we need is we expect that N1 and N2 needed to be large enough so that at least 10 successes, when I say 10 successes, I mean N1 P1 has to be greater or equal to 10 for the population 1, and N1 1 minus P1 also has to be greater or equal to 10. This is for the population 1, and for the population 2, N2 P2 also has to be greater than 10. Then N2 into 1 minus P2 also has to be greater than 10. Now, these are the conditions under which, we can assume that the point estimate of, the point estimate now, the difference of this is actually going to follow normal distribution. Okay, that is what will enable us to apply the formula now. Okay, now which means if you want to construct an interval estimation, okay, the assumption required, the assumption needed is that we need to first investigate whether this they have to be at least 10. Okay, that's exactly what I mean. And of course, if we're constructing a confidence interval, we're also going to have a point estimate. We're going to have the margin of error, and of course, the margin of error we're going to make it of a z. Okay, we're going to be checking from z. Okay, now I want to go into the last sample confidence interval now for P1 minus P2. There are two assumptions. Assumption number one, the sample you're going to be taking from the two population are to be random. And assumption number two, at least 10 successes and 10 failures in both samples. That is what I mean the other time by, by doing this. Okay, this guy here, okay, for the first population, 10 success, the successes N1 P1 must be greater or equal to 10, and the failures N1 Q1 must be greater or equal to 10. The same thing also go with the second one. Okay, we got to ensure that. Okay, the same thing also go. Okay, and don't forget, when I say Q1, I mean 1 minus P1. When I say Q2, I mean 1 minus P2. Okay, so I need you to take notes of all of that. Now, what is now the formula that we're going to use for confidence interval? Okay, what is the formula we're going to use for confidence interval is this guy here. You see that guy now? That is the formula we're going to use. Now we take a look at this. This is a point estimate. This is the standard deviation that we can also call standard error. This is the Z. So when I multiply, I call this guy standard error. And this guy is, a Z score. So which means when I multiply the Z score by standard error, that gives us margin of error. Everything gives us the margin of error. So the margin of error is when you multiply the Z score by the standard error. Okay, take a look at that. Okay, now we're gonna go, how do we interpret our confidence interval? If we want to interpret our confidence interval, we're gonna pay attention, to whether the interval contains zero or not. When the interval is from negative to positive, that will contain zero. Okay, and when it contains zero, it means there is no significant difference. I'm going to say that again. When the confidence interval contains zero, what that means is there is no significant difference. Okay, there's no significant difference means there's no significant, the difference is not that significant, even though difference exists. But it is the one that can be attributed to chance variation. So the difference is not significant. That's what we mean. And that's when we have from negative to positive. But what of in a situation, okay, if all the values in the confidence interval are greater than zero, you may have positive to positive. You know what I mean? It means the proportion, the first proportion is greater than the second proportion. That's what I mean. And if all are negative, negative, of course, the first proportion is less. So what number two here is telling us, whether you have a negative, negative, or you have a positive, positive, that indicates significance. Okay, that indicates significant difference. Number two here is talking about significant difference. Okay, while number one is talking about not significant. Or somebody said if you pick a confidence interval of 99.9999, won't all margin of error include zero, therefore meaning of comparison. And that is, yeah, you are very correct. Actually, it is not reasonable to choose 99.999. 99.999 is more or less like 100% level of significance. And we don't have that kind of situation in the world where our model is going to be perfect. So the idea of choosing 99.99999 is out of play. Okay, we don't consider that in research. Okay, even though we want our error to be small, but not extremely small, that our model will be very close to reality. Our model can never give us exact picture of reality. Oh, so that's what I mean. Does that make sense? So, and that is why in research, the standard level of significance we normally use is 5%. That is a reasonable one. If I use a 5% level of significance, then it means the level of confidence will be 95. At times we use 99%, but not 99.99. So 99.99 is trying to tell us that our model is the same as reality. So model can never be the same as reality. I hope I've answered the question. Somebody will chat with me right now. Okay, thank you too. Now we want to go into an example. We want to go into an example right now. The NCAA requires colleges to report the graduation rate of their athletes. In a sample of former male and female student athletes, 43 of the 53 female surveyed had graduated. I need you to take a look at this. This is actually talking about some college students who also do sports. Okay, some college students who also do sport. Of course, my daughter in high school also is into athletics as well. So now, if you take a look at this now, we got some females that do sport, we got some males that do sport, but right now, I think what this question is actually talking about is, can we trying to construct a 99% confidence interval for the difference in true proportion of female athletes who graduate and male athletes who graduate. Okay, we actually want to see whether there's a difference between them. Those who do sports, we're comparing the graduation rate of female and male right here. Now, the very first thing you need to do is to investigate, what are the assumptions. Okay, assumption number one is that we are taking two independent random sample. Two independent random sample means the 53 females that I choose here, I choose it randomly. Okay, where I choose the 53 female randomly. Okay, and I also choose 102 males randomly that have graduated, because in this college, it is not only 53 females that graduated, it is not only 102 males that graduated, but we've chosen 53 females and 102 males randomly. And how do I know? Take a look at this. Do you see that? In a sample of former that and that, we want to believe if any reasonable sample should be actually be chosen randomly. Now, another thing we need to do is to investigate N1, P1, is it greater or equal to 10? Okay, now my N1, if you take a look at, we're going to investigate that whether it's greater or equal to 10. We're also going to indicate for NP, whether that is also greater than 10. We're going to do for N1 into 1 minus P1, whether it's going to be greater than 10. We're also going to investigate all of that. But if you want to investigate, why can't you first get what is the proportion of female? Okay, 43 out of 53. What is the proportion of male? Okay, if I want to investigate now, okay, so if you take a look at it, I got PF and I got PF. Don't forget, I put a cap on them because this is a sample proportion. Now, the next thing I'm actually going to do after getting that, okay, is I can investigate whether this actually hold. Okay, or what I'm just going to do, NF, PF. Okay, what is NF? Here, 53 multiplied by what is PF? Okay, the PF is 0.811. Of course, at the end of the day, that will give you 53. Or let me see. That's going to give you 43. Okay, if you multiply that, okay, 43 here is greater than 10. and 58 here is also greater or equal to 10. So that assumption is met. The next thing now is assumption made. I'm actually going to go into the formula. Okay, take a look at this. This is the formula. Okay, the confidence interval. Okay, I've already obtained my P cap by P cap the other time I was using P1 and P2. Okay, it doesn't matter. Okay, right now I'm using PF. I'm just trying to say, okay, proportion of female. M is for female, F is for female and M is for male. So take a look at that. Okay, now what I'm doing now, plugging in the values now. That's what I'm doing. You can take a look at all of that and plug in the values. Now, after plugging all those values, the next thing is, how do I get this? They're talking about 99%, right? Now, if I need to get an alpha, is going to be 1 minus 0.99 because they say 99%. 99% is 0.99. Okay, now that's going to be 0. Is it 0.01? Okay, if that is 0.01 alpha, then don't forget, you're going to do alpha over 2. That will be 0.01 divided by 2, and that will be 0.005. And that was why. Take a look at that. If I'm going to go into the Z table now, if I go into the Z table, I'm actually going to check, okay, the Z score that corresponds to 0.005. And that's going to give me 2.575. Okay. And at the end of the day, when I actually get all of that, calculating that, that's going to give me that. When I subtract from 0.242 and I add to 0.242, then this is what I got. Now, when you take a look at this, there is no zero in the interval here because this is from positive to positive. From positive to positive right now, okay, what that actually means, from positive to positive, it means this guy is likely greater than 0. Okay, of course, you can see the proportion of female is more than the proportion of male. I told you the other time, when the two bound are positive, what that indicates is that PF is greater than PM. And in this case, it's trying to say significant difference exists. There's no 0 in the interval. So if I really want to interpret this guy now, I'm actually going to say we are 99% confident that the true proportion of female student athletes that graduate is between the 0.055 and the 0.429 higher than the true proportion of male student athletes that graduate. So, which means based on the sample we have analyzed, we can see that female athletes, have more graduating rates compared to the male counterparts. That is what it means. Is there any question about this? Is there any question? I need someone again to confirm if you're still hearing me clearly. Is everyone still hearing me clearly? Is everyone still hearing me clearly? Okay,
Yes.
thank you so much. Thank you for confirming that. Now, another thing I want to talk about, do you know that when I work on the same question, like if you take a look at this question now, I got this for 99%, right? If you can try for 95% and you try for 90%, for 95%, for 90%, for 99%, the Z score was 2.575. For 95%, it's going to be 1.96. For 90%, it's going to be 1.645. Now, what I'm going to notice, what I notice is this. When the confidence level is increasing, I'm going to say that again. When the level of confidence increases, maybe from 90 to 95 to 99, then the range will be wider. You're actually going to have a wider range. Okay, you can try that. Okay, I'm going to say that again. When the level of confidence, like right now, for 99%, I got this. Now, when you try to get the range for 95, it will be narrower. The one for 95% will be narrower than the one for 99%. And when you try the one for 90%, the one for 90%, you're actually going to say will also be narrower than the one for one, for 95%. Why do we have that? And I'm going to tell you right now, the more confidence you have, then that will actually make the interval to be wider. Just like what somebody told me the other time, for 99.999, which is 100%. If you write an exam and you ask me about your score, maybe you have not seen your score. Okay, maybe you have not seen your score. And I say, Professor, can you tell me my score? And I said, 100% confidence your score is going to be between 0 and 100. That's so wide. Of course, your score is going to be between 0 and 100. I'm 100% sure. But that is very, very wide. That doesn't make sense. And that is the reason why we don't want to use, highest level of confidence. Because when your level of confidence is very close to 100%, okay, that is not realistic. I'm going to say that again. If your level of confidence, okay, is very close to 100%, that is no longer realistic. You know why? Why is no longer realistic? Because you're actually going to have a very wider range. Having a wider range is complicated. It doesn't really make a kind of sense in a way. And that's the reason why we got a standard. The standard that we normally use in research is 95%. Okay, and when your level of confidence is 95%, it means you are ready to mislead the world 5 times out of 100. Misleading the world 5 times out of 100 means you are 95% confident. Okay, so that is just the takeaway. I think somebody's chat with me right now. Somebody said it's 99, 95, 90, the most common confidence interval. My answer is yes, but I can ask you 90 to compute 92%. I can ask 98%. Okay. All we just need to do, how do you check for those in the table? But the most common one, you are very correct. We use 90, 95, 99. These are the most common one. And you know what? If you actually tell the world you are 90% confident, okay, it means your level of significance is 10%. The level of significance is the level of error. If you are 95% confident, your level of significance is 5%, which is 0.05. Okay. Your level of significance is the level of statistical error. If you are 99 right now, okay, then it's going to be 1% level of significance. Now, so that is it. Those are the common one that we got. Is there any question? Is there any question? Somebody want to ask? Is there any question? Okay, so this is going to be the end of chapter 9. Of course, when we come back from Thanksgiving break, uh, on Monday, we're actually going to start chapter 10 that we actually call hypothesis testing. Okay, chapter 9 talk about estimation, where we talk about both points and interval estimation. But chapter 10, we're also going to talk about 1 and 2 population. Okay, we're going to test, hypothesis. And that's what we're going to, and like I said, what we're doing now, chapter 9, let me just say chapter 7. Let me see, is this chapter 7 or maybe chapter 8? Yeah, chapter 8. We didn't do chapter 7. Chapter 8, chapter 9, chapter 10, they are very, very crucial in this in the final, like I said, 60%, weight. They're all going to have 60% weight in the final. So, and I need you to pay attention to what we're going to be doing now. Okay, as I promised in my last class, I've already published exam two. Okay, solution. Exam two solution is already on the canvas. Okay, for those of you, like I said, I regraded question 19 and 20. Oh, sorry, is it 2021? Oh, 2021 for everyone. I give everyone full credit. If there is anyone who is impacted? Somebody said, is final difficulty similar to the midterm one and midterm two in the chart? All what I just know is this. In the final, you're actually going to have more time spent because the final exam is 2 hours. It's going to be conducted in person. Okay. And, it's actually going to be the same number of questions. So, but all what I can just confirm to you is the same way that I did in midterm one and midterm two, where I actually had a preview on that. I'm also going to have that's for the final as well. Okay. So in the final, okay, uh, it's going to be, uh, a combination of multiple choice and, short answer. So, you know, the chapter we're doing now, the one I said that's going to take 60% is going to be short answer. Okay. Why the one you've done before that I said 40% is just going to be multiple choice. Okay. So, and the exam is going to be in person. The final exam is different. The final exam at the beginning of the semester, the final exam has already been scheduled by the school. Okay. So, and I'm also going to allow a cheat sheet. Okay. I'm going to allow cheat sheet in the final. And of course, I'm going to give you information. Okay. About that as time goes on. And, I'm kind of happy about the performance in midterm two. It's better than midterm one. And I believe the final, you know, the performance, is also going to be great. But what I need to tell you is what I'm telling you now, what you need. I need you to pay more attention to what we are doing from chapter 8, chapter 9, chapter 10. 8, 9, 10, 60%. The 8, 9, 10, they're actually going to be the short answer in the final. They're going to be the short answer in the final, the one you're going to show your work, the one we're doing now. Okay, 8, 9, and the 10 that we're actually going to do. 10, we're going to start 10 next week, right? They're all going to be like 60%. The multiple choice will be 40%. The multiple choice will revolve around what you have done before. So, which means the multiple choice will revolve around topics covered in midterm one and topics covered in midterm two. And there's going to be 20 questions. Okay. There's going to be 20 questions for the multiple choice. There's going to be 20 questions, multiple choice, and there will be three short answer questions, three short answer that will revolve around chapter 8, 9, and 10. Three short will revolve around chapter 8, 9, and 10. And they're going to be what? They're going to what? 20, 20, 20. Okay. And that is 20 times 3. That's going to be 60, right? Now, somebody shared with me about practical. I don't know. Somebody said, what is practical exam? Or you don't want to say practical assignment, right? The person somebody shared with me right now say practical exam. I don't know what you mean. Do you mean practical assignment? The person that shared with me, I need you to clarify. I need clarification from you. Somebody said, what is a practical exam? Are you talking about practical assignment? Anyway, what I have is practical assignment. The last assignment of the semester, okay, the last assignment in the semester is a practical assignment. And that very practical assignment, I think I'm going to do this. Give me 1 second. Because I've seen that question that Actually, I'm going to share this with everyone now. Oh, give me 1 second. Okay, so I'm going to share this with everyone. I'm going to share my syllabus with everyone before I go. Okay, so going to um let me go to the syllabus. Excuse me. Now, if you take a look at this, you see 50% practical, right? Okay. Now, this 50% practical, if you are done with your assignment, okay, take a look at this. I'm going to show you something now. Now, we are currently on assignment 9, right? The last assignment that you're going to compete in the semester, okay, is going to be practical in nature. And that very assignment is not going to be, it's not going to be here. I'm going to put the assignment here. It's going to work 15%. And that practical assignment is more or less like an exam, but it's not exam. You know, it's an assignment. Okay. And if you go by my syllabus, you know, uh, you're actually going to see something here. Oh, give me 1 second. Okay. Take a look at this guy here. Do you see practical assignment? You see the practical assignment? It's going to be like a regular assignment. Okay. Now, this practical assignment, I'm going to give it like a regular assignment, and that very assignment is going to worth 15% of the grade. That is what I mean. Okay. Now, after assignment 9, okay, you know, you're going to have assignment 10. And don't forget, when you look at all the assignment here, okay, you're actually going to have 11 in all, right? Plus the practical. But let me tell you this, which means the original assignment is going to be 10, right? Do you see that? 10, 10. Now, out of the original assignment, I'm only going to use 9. I'm going to say that again. Out of the original assignment, you know, in all, there's going to be 10, right? Apart from the practical assignment. Okay. In all, there's going to be 10 apart from the practical. Okay. Now, out of this very 10, I will automatically drop the assignment with the lowest score, which means I'm only going to use 9 assignments out of 10. Okay, but the practical assignment is different. The practical assignment is just going to be the last assignment in the semester that is just going to be practical in nature. Okay, practical in nature is just going to reflect, you know, it's going to look practical, right? But it's computation, so it's easy, something that you've done before. It's just to test your practical knowledge of what we've done. There's no any big deal. Okay. Now somebody says, so does our assignment drop only apply to the exactly? Assignment drop apply to the regular assignment. Out of 10 regular assignment, I'm going to drop 1. So for those of you who did not complete 1 assignment, I will automatically drop that. So which means you can still have A in this course. Is there anyone who want to ask question again? Is there anyone? Any clarification on that? So like I said, somebody said, could I speak with you later after class? Okay. Yeah, you can. If you want to speak with me later, you're going to wait until everybody is done. If it is, everybody is gone, if it is private, okay? And I'm going to stop my recording if you want to speak with me in privacy, okay? I'll stop my recording. Okay, so in the absence of question, this is where I'm actually going to stop. Somebody said, can you explain the practical assignment again and its weight? It's 15%. The practical assignment is more or less like an assignment, except that it has some practical stuff in it. That's all. just to test your knowledge of what you've done before. So it's going to be easy and you're going to have a lot of time completing that. So, okay, make sure you all stay safe and have a lovely day. Bye for now. I'm going to stop my recording for somebody.
These two groups separately.